Okay, welcome to Data Focus Python Week 2. I'm going to start out this lecture by wrapping up the couple of things that I skipped at the end of last week, starting with modules and then taking a look at copying a text file. So a module in Python is a file containing code that you can do what's called importing into your current program, and then you can execute functions contained within that module or access variables contained within that module. For example, the math module, that's one of the standard modules available with Python, includes a number of commonly used mathematical functions. If we would like to compute e to the x, let's say, the function for that is exp, but by default, that function is not available. We need to gain access to that function by importing the math module, and then we can say math.exp1 to compute e to the 1. All right? Now, math is not a terribly long name, so it's not too annoying to have to type out math dot and then exp to access that function. But often people import modules using an abbreviated name. And to do that, we would say something like import math as m. So in other words, import the module as some abbreviated name, and then we can simply say m.exp to access that exp function. We can also use cosine, m.cosine of 0 is 1, m.square root of 2 is 1.414, etc. m.log of some number there's the natural log of that number, and so on. If all I'm interested in from the math module is one particular function, I can import from that module the particular function that I want, and that will elevate this function into the top level or global so-called namespace of my Python session. So now I don't need any prefix at all. I can just say exp1 to access that e to the x function. You can, but it's very risky, say import from some module everything. Okay, so from math import star. And this pulls every function, every constant value, every class, whatever is defined within that math module, into the top level global namespace. Now the problem is that it's unlikely that you know all of the names that are available in that math module. I certainly don't. I mean, I know a great deal about what's in the math module, but I cannot pretend that I know every single name that's available in that math module. So if I had previously defined some function named, let's say, log, that I was using as part of a lumberyard management application, well, by saying from math import star, my existing log function would have been overwritten or replaced, if you will, by the math module's log function. All right, so this is convenient but risky. It's definitely not something that you want to do within a program that you store in a file. You can do it interactively if you're pretty confident that you know what you're doing, and if you're not going to have a really long session where you're really concerned about potentially damaging parts of your logic. In any case, pi the value of pi out to 15 or 16 digits is defined within the math module. If I ask for the sine of pi, now the sine of pi ought to be 0, but the sine function can't compute exactly 0 for that. And if I continue passing that value to other functions, you'll notice that my error keeps growing here. This is one of the challenges with any kind of floating point mathematics that you do, is that the more computation you do, the more round-off error you tend to accumulate. So what I should be computing here is e to the 0, which is exactly 1, but what I'm getting is 1 with zeros only out to the 7th digit after the decimal point, and then I have this garbage hanging off the end. All right, so that's a bit about importing modules, and in particular the math module. We'll be creating and importing modules of our own a little bit later. Next, we're going to take a look at how we can read from a text file on disk and write to a text file on disk. In this example particularly, we're just going to make a copy of a text file. Now, you have to know which file it is that you want to open to read from, and you also have to know which file you want to create to write to, and those files are going to be located in some directory, or perhaps different directories, somewhere on your system. If you're using a Linux system or a Windows system, then if you're using if you're using a Linux system or a Mac system, then you're accustomed to using the / as the directory separator in a directory tree. But in Windows, we use the / normally to access, to specify directory levels. However, the / has a special meaning in Python. Recall that if I print, let's say, hello \n world, that the / has a special meaning in a string in Python, which in this case causes the n to be treated as a new line character. So \n is a new line character for Python, and therefore it's risky for me to type path names like \users \jostland \documents \neuter and so on, because although capital U and capital D and I think J is okay, the \n here is going to be treated in Python as the new line character, not as the first character in a subdirectory name. Consequently, even in Windows, it's fine to use a / as your directory level separator, and that'll work on Windows just fine. Now, I do happen to have on my system a directory named, well, let me open this file. I'm going to say fn is, or gets open of, and this is a file that I do have on my system, /users /jostland /dfp a4 2020 /expenses.txt. Now, that expenses.txt file is a file that we will be using later on in homework assignments. For now, it's just a text file, so it provides me with an example that I can look at. That is the file that I want to open. This is going to be my input file. To open an input file, what I want next is to say that I'm going to... I just noticed that I forgot my comma at the end there, so I'm going to type my comma here. And RT indicates that I want to read text from this file. Now, different text files can be encoded in different character sets. And for us, we're going to specify that the encoding of the file is UTF-8, UTF-8. It turns out that the UTF-8 is the most widely used character set for information found on the web. And for us, luckily, UTF-8 incorporates the 7-bit ASCII character set within it. Okay, so it's a natural subset of UTF-8. This does happen to be an ASCII file. So when I hit the Enter key now, either it's going to work and successfully open that file, or I will get complained at. Cool, it worked. All right, so I have now opened that file for input, and I've got my fin variable referring to that open file. I want to copy this file to some output, which I will open. And let me just create this in users josland downloads expcopy.txt. Okay, so I do have a users josland downloads directory on my system. I'm going to create a file in there called expcopy. Now, the distinction between an input file and an output file is, whereas I said I want to read data from the input file, I'm going to say that I want to write text to the output file. Okay? And by using the W here instead of the R, that tells Python to create that file if it didn't already exist, or to open that file to be overwritten if it did already exist. My encoding for the output file is also going to be UTF-8. And now I have, cool, my input file and my output file are both open. It turns out that this input file is iterable in the same way that a list is iterable, or that a stir is iterable, or that the range function produces an iterable. And each time I read from that input file, what I'm going to get is a line of text into a string variable. I can use a for loop to process this iterable. So I'm going to say for line in fin. There's nothing special about this variable name line. I could have just as well said for ASDF in fin. But what I'm going to get from fin each time is a line of text. So I'm just going to use the variable name line for that. And what I want to do each time I read a line of input is to write that line of input into the output file. So when I hit the Enter key, again, this should run, and it'll go pretty quickly. It turns out that the f.write function will return the number of characters that it wrote out each time that it's called. So apparently the last line of output from this file was 32 characters long. If I write the string hello, for example, then I see that that's 5 more characters that are added to the end of that file. Actually, I should be careful and add a new line character as well, so that that's a full line of text in the output file. Now, when I'm done using my files, I should close both of them. It's less important to close the input file because we're only reading from the input file, and there's not much chance of damaging that. But just for completeness, I'll say fin.close And for certain, I need to say fout.close. If you're dealing with a large text file, what's going to happen is that as you write data to this fout file, some of that data is going to be buffered in memory between your program and the file on disk. And if your program prematurely terminates, you may discover when you look at that output file later that not all of the data was actually written out into the file. So by explicitly closing the file, you ensure that all of the data that was supposed to be written into the file is actually written into the file. And now if I pull up an ordinary terminal, let me pull up a terminal here and drag it to where we can look at it. Okay, so here's a terminal, and if I go into downloads and do a dir of exp copy.txt, okay, there it is. It has 1,511 characters in it, and if I type it to display it on the screen, all right, I see that it has all of the lines from the expenses.txt file. Now, I didn't actually show you that original file, but trust me, these are the correct lines. And here at the very bottom are the 6 additional characters that I wrote. That is the H, E, L, L, O, and the new line character to conclude that line of input, or that line of output. Okay, well that takes care of modules and how to copy a text file. We're going to move on now to this new material for week 2. We've looked at lists. In this new lecture, we're going to talk about more collection types. We're also going to talk about converting back and forth between different types. And the second half, it doesn't seem like that many slides, but it takes quite a bit of time to go through. The second half of this week 2 lecture will be web scraping, that I'm not going to try to incorporate as part of this lecture video. Okay, so we've looked at lists. We also need to talk about some other built-in data types, namely tuple, set. Frozen set is the same thing as a set, except that you can't change its members. And later on, we're also going to take a look at something called the dict, or dictionary, data type. Okay, so a list has elements that we can change, and we define a list interactively by saying square bracket and giving some values, and now we have a list of those values. A tuple is basically the same thing as a list with an important exception. You cannot change the items contained in a tuple. All right, so a tuple can be defined by giving values in not square brackets, in parentheses. So when you use parentheses rather than square brackets, that's how you define a tuple. And here I'm creating a tuple of stirs, a tuple of strings, a golden eagle soars, we see that is a tuple, and if we display it, we see that it displays as a tuple in parentheses. Now we can access items in a tuple using the same index values that we use in a list. That is, if there are n items in the tuple, we can use indexes from 0 up to n-1. We can also go in reverse order from -1 for the last item in the tuple to -n for the very first item in the tuple. Okay? So, in other words, n sub 3 is source, n sub minus 3 is golden, n sub minus 4 is ah. And if I go outside the bounds, I get yelled at, as we did with the list. Notice that even though I define the tuple using parentheses, I nevertheless use the square brackets when I want to index a particular item within that tuple. Now, a tuple is what's called immutable. That is, you cannot modify the items in a tuple. With a list, okay, here we have this list M. I can say M sub 2 gets hello, and that modifies the sub 2 item within M. But for n, if I try to say n sub 1 gets bald, okay, so that would change my tuple to a bald eagle soars, I get yelled at instead. Okay, so a tuple, once you have defined it, cannot have its items changed. However, you can simply create a new variable, or in fact use the same variable again to refer to a different tuple whose contents have been modified. So although I can't directly change n by saying n sub 1 gets a new value, I can say n gets n's sub 0 item, and then bald, and then n's sub 2 item, and n's sub 3 item. This creates a brand new tuple and changes n to refer to that brand new tuple, which is now a bald eagle soars. It turns out that if you have a tuple, you can do what's called unpacking that tuple, or in general, unpacking a sequence, into multiple separate variables. So I have this tuple n that contains 4 values, and if I say A, B, C, D, separated with commas, gets n, the effect is that the first item in the tuple, the word a, becomes the value of the variable a, bald becomes the value of the variable b, or I should say the value that b refers to, eagle is referred to by C, and soars is referred to by D. So I have successfully, through this so-called sequence unpacking, assigned the individual items within this tuple to 4 separate variables. Now this is called sequence unpacking as opposed to tuple unpacking, because actually any sequence will work. A list is also an example of a sequence, and a stir is another example of a sequence. So if I say, let's say M, comma, N, comma, O, comma, P gets M, whoops, I don't want to say M gets M. Let's say I, J, K, N. I never like to create a variable named L because an L looks far too much like a 1. In fact, you can see that there's only a couple of pixels of difference between the L and the 1, so I like to stay away from L. All right, so I'm going to say I, J, K, N. Just realized that N is my tuple. I don't want to use it either. So I, J, K, P gets M, I, J, K, P. And I have unpacked the list sequence into those 4 variables. Okay. Now, you can also use, on the other side of the equal sign, what's called tuple packing, which basically allows you to define a tuple without even using the parentheses. So I created n by using parentheses, but here I'm creating a tuple called t by just giving a sequence of values separated by commas, no parentheses, and yet t is nevertheless a tuple. Okay, so we have sequence unpacking on the left side of the equal sign, tuple packing on the right side of the equal sign, and we can combine these two ideas together to create something called multiple assignment. And this is something that's frequently used in Python, partly because it's cool and partly because it's useful. If I say A, B, C, D, separated by commas, gets high 2.6, true 9, well, in effect, what we're doing here is we're creating a tuple on the right-hand side of the equal sign, and then we're unpacking that tuple into these variables on the left side. And it just allows me to, using a single assignment statement, store or cause A to refer to the string high, B to refer to 2.6, C to refer to true, and D to refer to 9. The most common use of multiple assignment actually is to swap the values of two variables. It allows you to swap values of variables without having to create a temporary variable to act as an intermediate during the swap. Here I've got A getting -7, B getting 3, and if I say B comma A gets A comma B, well, the value of A is obtained, and the value of B is obtained, and those values, respectively, become the new values of B and A, or the values that B and A refer to. So B now refers to -7, and A refers to 3. Okay. So we created a couple of tuples containing 4 items, namely n and t. If you want to create an empty tuple, you can do that by just using an empty pair of parentheses. All right, so t displays as an empty pair of parentheses, and the type of t is tuple. You can do the same thing for a list. You can say m gets open close square brackets, and now m is an empty list. But recall that the parentheses are also used just for specifying ordering, like overriding precedence or associativity kinds of rules. So if I try to say something like t gets parentheses 6, my intention probably is to define a one-item tuple containing a 6 and have that assigned for t to refer to that tuple. But in fact, 6 in parentheses just has the value 6. And so t is not a tuple in this case. T is simply an int. What I have to use is a sort of goofy notation of a value in parentheses with a comma after it to handle this one awkward case where I want a tuple with a single value. So I say t parenthesis 6 comma, and now t is a tuple, and it only contains the 6. If I ask for the length of t, I get told that that's just 1. Okay, so saying that a tuple is a sequence has important meanings. What it means is that things like subscripting and also slicing will work for a tuple just like they work for a list or a string. Here's my tuple n, and if I ask for n sub 1 : that means give me everything from item sub 1 up to the end of the tuple. So this is a tuple of 3 items. Or if I say tuple sub 1, that gives me a tuple of all of the items up to but not including 1. So this is a so-called one tuple just containing the word a. And notice that because it only has one value in it, in the representation that's displayed, there's a comma after that value. All right, so here's yet another way of making a tuple, well, making the variable n refer to a different tuple, a different kind of eagle in this case, a harpy eagle. N sub 2 colon. Okay, so what I'm saying here is n sub colon 1, that means everything up to but not including item sub 1. So that's going to be the tuple a. Then I've got another one tuple here, harpy with a comma after it, followed by n sub 2 colon. Now n sub 2 colon is going to be this tuple of two values, eagle and soars. The upshot is that I now have, by using concatenation, just like I can with lists or with strs, I can concatenate multiple tuples together to get a single tuple. So now I have a harpy eagle soars. And I know there's other kinds of eagles in the world, but off the top of my head I can't think of any. I'm out of eagles, so we're going to have to abandon this example. All right. Next up, we're going to take a look at sets. A set you define by using, or you can define by using a pair of curly braces. And when you display a set, it displays in curly braces. The deal about a set is that items in the set are not sorted in any particular order, and no duplicates are permitted within the set. Although if you define a set and you give duplicate values, all that happens is that the duplicates get dropped. You don't get any kind of error message. So here I am saying, and let me copy and paste so I don't have to manually type all this stuff in. So I'm going to say S gets a set of values. Whoopsie. Oh, that's my... Okay. That's a video for a different class. All right, let's try this again. All right, so I'm going to copy that. There we go. Okay, so I've got 165921163. You'll notice that there's a couple of 1s in there. There's a couple of 6s in there. Those duplicates get tossed out. And when I display S, I see that it contains 6 values, 1, 2, 3, 5, 6, 9. The type of S is set. And you see when I display S that I do have the curly braces. Now, I just got done claiming that items in a set are unsorted, and yet in this example it looks pretty much like the items are sorted. But I promise you that's just random from this particular example, and it is not true that items in a set are sorted. Now, a set is not a sequence, unlike a str or a list or a tuple. I cannot access the sub 1 item of a set because the set has no concept of ordering. What I do have for the set is a collection of named operations that I can do to interact with the set. For example, here's my set S. If I say s.add 7, let's say, now my set has a 7 in it. That still looks suspiciously sorted, but I promise that's an illusion. If I say s.add 3, 3 is already in the set. However, the add function does not complain. It simply does not add 3 a second time to that set. I can get rid of items from a set using a couple of different functions, discard and remove. The distinction between them is that discard will make an attempt to discard a value, but it will just silently fail if that value isn't there, whereas remove will complain. All right, so here's my set S. If I say s.discard a 7, the 7 is gone. If I say s.discard 13, well, there is no 13, but that's okay. Discard tried to discard the 13, but there wasn't one there. Remove, on the other hand, is more easily upset. If I say s.remove 2, that worked fine. There was a 2 in the set. If I say s.remove 13, I get yelled at. Okay, there is no 13 in the set, and consequently s.remove fails in this case. Now, I can also pop a value from the set. And there's no guarantee about which value I will get when I do this. So if I say s.pop, all that I know is that I'm going to get some arbitrary item from the set returned, and because I'm typing this in the shell, it will therefore be displayed as well. All right, so there was one value that was popped. And if I say s.pop, I get another arbitrary value. All right, now I keep claiming that I keep claiming that sets are not sorted, and I keep claiming that these values that pop returns are arbitrary, and yet it looks very much like they are sorted. No, I promise. It's just an illusion. The items in a set are not sorted. I can detect whether a particular value is in a set by using the in test. So I can say 9 in S, that is true. 13 in S, of course, is false. And if I wish, I can clear all of the values from the set, but I don't actually want to do that. I want to leave my set alone. And in fact, I want to append a few more values, or add, pardon me. Okay, append would imply putting something at the end, but a set doesn't have a concept of a beginning or an end, so all we can do with the set is add things. So let me add a 1, let me add a 3, let me add a 13, let me add a 6. Oh, there's already a 6, that's okay. That add just got ignored. Okay, so now I've got my set built back up to having 6 values in it. On slide 12 and slide 13, we have examples very similar to the ones that I just went through. So I'm gonna skip these couple of slides, 12 and 13. Now, so that's how we can either add or remove or test individual values within a set using those named operations. I can also do set versus set comparisons. For example, let me create another set. I guess I have an example on the next slide. So here's S. Let me make sure that my S is exactly identical to what I have on slide 15 here. I'm just going to redefine S altogether. In fact, I will cheat and copy and paste so that I don't have to do this manually. And we'll hope I actually get a copy in this case. Okay, worked that time. All right, so there's S. And I'm going to create S2 as well as a copy of this thing. All right, so now I've got S and S2. I can compute the union of the two sets, which has the obvious meaning. I can compute the intersection of the two sets, which likewise has what I hope is the obvious meaning, values that are in both sets, versus for the union values that are in either set. The set difference is the values that are in S1 but that are not also found in S2. Let's see what that one's about. All right, so if I say S dot union S2, what I'm going to get is a set that contains the values that are either in S or in S2 or both. And that's going to be 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. All right, I'm still claiming that these things are not ordered, despite that they look like they are. Let me ask now for the intersection of S and S2. Oh, check this out. Check it out. Check it out. The intersection is the values that are in both, and 9 came out before 3. I did promise that these were not ordered, and now we finally see an example. Let me, in fact, capture this into a set S3. So S3 gets S dot intersection S2. Here's S3, and now if I say S3 dot pop, check it out. I didn't get the 3. Now, it does seem to be returning the first item from the set, but there's no guarantee of that. That's just an artifact. All that's guaranteed from pop is that I get some arbitrary value from the set. All right, let's take a look at the idea of the set difference. Here's S, here's S2. If I ask for S minus S2, what this is going to give me is all of the items that are in S with items that are also in S2 eliminated. So in other words, it's basically S minus the intersection between S1 and S2. Therefore, what I get is S with the 3 and the 9 removed. Set difference is not a commutative operation like intersection or union. That is, if I say S dot union S2, this is a commutative operation. I can say S2 dot union S, and I get exactly the same thing. But set difference is not commutative. S minus S2 is the values that are in S that are not also in S2. S2 minus S is the values that are in S2 that are not also in S. All right, so I get disjoint lists. All right. I can also find out whether two sets are disjoint. I can find out whether one set is a subset of another one or a superset of another one. Now, it has to be the case that S is a subset of S union S2. All right, that has to be true. Well, I made a typo there. S union S is just S, but S is a subset of itself, so that's fine. It's not the example I wanted to show, but it works. Okay. All right, so onward to slide 16 here. It turns out that we can use symbolic operators to compute things like intersection, union, and symmetric difference, as well as, and set difference, as well as symmetric difference. And these things have this precedence. That is, of these four operator symbols, the ampersand, which is and or intersection, has the highest precedence. The vertical bar, which means or union, has the next highest precedence. The hat symbol or caret symbol, which stands for exclusive or symmetric difference, is next, and then set difference is last. So if I have, all right, so I've got S and I've got S2. If I say S and S2, and is intersection. So it means give me the items that are in S and that are also in S2, and so I have the intersection. If I ask for S or S2, that means give me the items that are in either S or S2 or both, so that's the union. And set difference, actually I just realized I skipped a step. I jumped ahead and used the minus sign rather than using the dot difference named function. So we've already taken a look at the set difference. Let's take a look at the symmetric difference. Okay, so here's S, here's S2. Symmetric difference, the exclusive or of two sets, is items that are in S or that are in S2, but that are not in both. Okay, so this is going to give me the items that are in S or that are in S2, but that are not in both S and S2. Okay, so 4, 5, 6, 7, 8, 10 are the values in that exclusive or. Now, the exclusive or here can be thought of as the union minus the intersection. Okay, so S union S2 is the values that are in either S or S2, or both. But then if we remove the items that are in both, what we have left are the items that are in S or S2, but not both. Sorry. And I have to type and for intersection rather than exclusive or. All right, so moment of panic, but yes. Oh, duh. So now, so now I'm getting precedence problems. S or S2 is the union. S and S2 is the intersection. S or S2 minus S and S2 is the symmetric difference. All right, well, I apologize for that fumbling around. But I guess this does illustrate that keeping track of operator precedence is important. And okay. Now, what can you put in a set? Well, the values that you can put in a set have to be what are called hashable items. And hashable has a very technical, kind of long-winded description that I'm going to slightly simplify. Something is hashable, first of all, if it's a scalar. So all of the scalar values that we have are hashable values automatically. Furthermore, it turns out that a tuple is hashable if all of the items that the tuple contains are hashable. Now, a tuple is immutable. That means its values can't be changed. That means that it can always be mapped to a particular hash value without risk that it will change accidentally. Lists and sets, on the other hand, because they are mutable, are not hashable. That is, if you have a list, okay, let me say m gets 1, 2, 3. M has an ID. If I say m.append 1, 2, 3, 4, and I look at m has changed, but the ID of m has not. So what we have here is a situation where I am allowed to change the items within a list, so I cannot store a list within a set. All right, so those things are not hashable. So here on slide 18, we have this long-winded example. S3 is a set containing the int 5, the float 4.7, the special value none, the stir hello, the value true. Now, all 5 of those things are scalar values, okay? Ints, floats, none, stir, and booleans, those are all scalar values. I also have here a tuple, 3, 9, 14, and all of the items in that tuple are scalar values as well. Consequently, all of the items that I've tried to store into S3 here are hashable, and therefore that is allowed. Notice that here, ordering doesn't even make sense for things like booleans and none and stir. So the order that I have in S3 here is just, well, it is whatever it is. It's just arbitrary. All right, so we've looked at lists last week. Now we've looked at tuples, which are like lists, except they are immutable. And we've looked at sets, which are unordered and only contain one copy of each value. And you're restricted with sets to only using hashable values. Okay, so now we know about lists, which are mutable sequences, tuples, which are immutable sequences, sets, which are not sequences, but which contain individual copies of hashable values that are said to be in the set. And the fourth collection type we need to know about is the dict, or dictionary. And a dictionary does not contain individual item values. What it contains is pairs of values. These are called key value pairs. Like a set, we create a dictionary interactively by using curly braces, but we need to use a colon to separate the key from the value in each key value pair. Now the keys are restricted to be hashable, just like the set, and you cannot have the same key appearing more than once in a dictionary. There's no restriction at all on the value. It's perfectly fine for all of the values to be the same as each other. For that matter, it's perfectly fine for all of the values to be none. But the keys have to be hashable and have to be distinct from each other. What I'm creating here is a dictionary called N2E, which is short for name to email. And what it contains is the names and the email addresses of 3 people that are perhaps in the same club as each other or something. I've got the key John, whose email address is jkostlund@gmail.com. That's suspiciously familiar. And then I've got Al, who's made up. And Al's email address is al@alcorp.net. And then Bob, who is also made up, and he's bob@basok.com. Okay, so this dictionary has 3 items in it. The first item has the key John and the value jkostlund@gmail.com. The second item has the key Al and value Al at Alcorp. And the third is Bob with value bob@basok. All right, the type of N2E is dictionary. Now, a dictionary is not a sequence. However, I am allowed to use the square brackets as an indexing mechanism, but instead of an integer subscript like 0, 1, 2, 3, I use a key. So if I say N2E sub, and then I use the key John, what I get back is the value associated with that key. I can also use that same kind of notation to establish a new item in the dictionary. Here I'm creating the key psi, and the value associated with that key is going to be psi at nou.edu. Okay? If I just look at the entire dictionary by typing the name of the dictionary N2E, I now see that I have 4 items in this dictionary. The first item is John with jkostlund@gmail. The second item is Al with value Al@Alcorp. The third item is Bob with value bob@basok. And the fourth item that I've just added here is psi at nou.com. Now I want to mention here, interesting. Okay, I thought I skipped it, but apparently it's, maybe it's coming up, or maybe I totally forgot to put this in my notes. But I want to point out that the items in a dictionary are stored in the order of key creation. So the first item in the dictionary here is going to be the item with key John. The second item will be the one with Al. The third item will be the one with key Bob. And the fourth item is going to be the one with key psi. A set does not guarantee any order about its items, but a dictionary in the most recent versions of Python does guarantee that the items are going to be in order of key creation. Now, if the key already exists, and I say N2E sub John, let's say, gets jostlund@andrew.cmu.edu. Since that key already exists, what's going to happen here is that the value associated with that key is going to be changed. So N2E now, notice that the value for John that used to be jkostlund@gmail is now jostlund@andrew. So that did not create a new item. It just updated the value associated with an existing key. Now, in addition to this subscripting operation, there are several named operations that we can use with dictionaries. For example, we can get a particular value for a key from a dictionary. And the distinction between the get function versus the square brackets is that if the key doesn't exist, get is okay with that. There's no complaint. But if I say N2E sub ASDF, and that key does not exist, I get an error. Okay, so get is an error-proof way of looking up the value associated with a certain key. I can use pop item, which will pop the last item from the dictionary. So if I say n-to-e.pop item and psi is my last item, psi is the one that's taken out, notice that that comes back to me as a tuple. The key is the first item in that tuple, and the value associated with the key is the last item or the second item in that tuple, and n-to-e does now have that final item removed from it. I can also request to pop a particular item with a particular key, and I can request to clear the entire dictionary, but I'm not going to bother demonstrating those. Okay, now here we have some more examples on slide 24 that I'll skip. I've done similar things. All of these collections, list, tuple, set, and dict, are iterable. That is, you can loop through the items that they contain. But a dictionary is distinct from the other three because each item in the dictionary has both a key and a value associated with it. And it turns out that the dictionary provides three iterables to us to allow us to iterate just through the keys, or just through the values, or through the key value pairs, that is the so-called items. So let me show you what I mean here. Here's my n-to-e. Oh, let me put psi back so that my... Oh, that's amusing. Okay. So I have a bug in my first output here on slide 26 because I'm still showing psi as being in n-to-e, but it's not. And if I ask for n-to-e.keys, what I get back is an iterable of just the keys. If I ask for n-to-e.values, I get an iterable of just the values. Whereas if I ask for n-to-e.items, I get an iterable of tuples, of key value pairs. So, if I now say for k in, well, rather than creating this intermediate variable here, which is kind of silly, let me just say for k in n-to-e.keys. Well, let's print k. And there we are. So the keys are displayed in the order in which the keys are created in the first place. So John, followed by Al, followed by Bob. If I say for okay, here we're adding another, let me do this example here. We're adding another key value pair to the dictionary. N-to-e sub Dave gets Dave at dave.org. So now my n-to-e is increased by 1, and if I say for k in n-to-e.keys, now of course I'm going to have one more key, and it will be the last key displayed by the loop. Okay. If I do a for loop on I in, now I'm just using K for key, I for item, and here if I display each value of I, each of these is going to be a tuple. Okay? So the first tuple is John, key John with John's value, and then key Al with Al's value, and so on. And I can do similarly for the values in the dictionary. All right, now just as a notational thing, we already talked about how to create empty and single item tuples and lists. Let's do the same thing for sets. Both set and dict, when you define them interactively, make use of the curly braces. So the first obvious question we have is, what if you just type curly braces with nothing inside? What do you get? Is that thing a set, or is that thing a dictionary? Is that thing an error? What is it? Well, it turns out that empty curly braces define an empty dictionary. Okay, so empty curly braces are a dictionary. If you want to create a set that is empty, what you have to use is this construction function called set with empty parentheses, and that displays as set with empty parentheses. So here I'm saying SE. All right, DE for dictionary empty, SE for set empty, and I can see that the type of SE is set. I can also see that each of these things is empty. If I ask for the length of DE, that's 0. If I ask for the length of SE, that's 0. I can ask for the length of any iterable thing, and in this case I'm told that both of these collections, the dictionary DE and the set SE, are empty. Now, we had this peculiarity when we created a one-item tuple. When we said T gets 6, well, 67, doesn't matter. When we said T gets 67, that didn't work. That just created T as a reference to the integer value 67. You recall that we had to use this extra comma here to create a one-item tuple. There isn't any ambiguity for one-item dictionaries and sets, because a one-item dictionary has to have both a key and a corresponding value. All right. So D1 here is a dictionary with just one item in it. And that can't be confused with a set containing one item, because the items in a set are individual items. They're not they are not key value pairs. All right, so there's no ambiguity about what you're doing if you create a dictionary with one item versus a set with one item. Neither the set nor the dictionary is a sequence, so you can't ask for slices, even though you can ask for individual values out of a dictionary using the square brackets. All right, so I can ask for D1, well, let me just use N to E. I can ask for N to E, if I can type, N to E sub John. That works fine. But if I try to say something like N to E sub John up to Dave, I'll get yelled at. Okay? So because the keys are not hashable, I can't use a slice in a dictionary. Okay, well, the next part here is going to be about conversions back and forth among the different data types, and I think we will leave that for the part 2, the week 2 part 2 video. So I'll sign off for this evening. Hope you are all well and taking care of yourselves. And I will get the remainder of this week 2 lecture videoed and posted tomorrow morning, Thursday morning, as soon as I can. All right, take care.